Hello everyone, this is Universe, the place where we learn about the entire universe, everything, and how it began, how it will end. So today we're going to be learning about direct integration of the integral of e to the n multiplied by x squared divided by tangent, or at least over tangent, to the negative 1 power of dx. Dx basically is just going to mean some boundary condition. Boundary conditions basically are going to mean something that can keep from diverging to infinity. Let's see if we were to graph it. Okay, now let's get started. Okay, now, so in order to integrate e to the n, what we're going to need to do first is this thing. You're going to need to look at the problem. Then we're going to need to do is then you're going to rewrite or simplify it. Then the way to re-simplify it is that you're going to need to do the integral of negative e to the n multiplied by x squared, which is going to be over tan 1, which then is going to be multiplied by dx, which then you're going to need to add a linearity to the problem. A linearity basically is going to need to be ultimately just adding the integral to a certain part of the equation, which then it can flow a little bit better instead of doing the integral to beginning. So then you're going to need to do negative e to the n, which then that's going to be over tangent to the negative 1, which then that's going to be equal to the integral of x squared over, which then that's going to be multiplied by dx. Dx always stays constant about the equation, by the way, in case you want to graph it. Anyways, by the way, if you wonder what we're doing right here, we're going to be finding the antiderivative of it. The antiderivative basically would mean that we're going to need to be finding a certain type of value of it. Anyways, so okay, sorry, I didn't explain that really well, did I? Well, sorry about that. Well, if you want to know what an antiderivative is, I can say at the end of the video, but first we need to do it real quick right now. So what we're going to need to do is then we're going to need to solve it for the linearity. So we're going to need to move the integral back to the beginning, which then we're going to need to do the integral. So we're going to do the integral of x squared, since e finally has been derived, or we have found common derivative of it. So then we're going to need to do x squared. Then we're going to need the integral of x squared to the dx, which then we're going to need to apply the power rule, which then is one of the common places of calculus. Which then what you're going to need to do is then you're going to need to do the integral of x to the n, which then is going to be antiderivative, which then that's going to be equal to x n plus 2, which then that's going to be divided by n plus 1, which then with n equaling 2, since to do 1 plus 1 equals 2, obviously, and it's going to be really easy. Ultimately, you just apply the power rule for different variables if there's any numbers throughout the equation, which then that is going to be equal to x cubed over 3. But we're not done yet. Which then we're going to need to do is then we're going to need to plug in all the solved integrals into it. So then we're just going to do what we did before. And in case you weren't listening because I was talking too fast, what we're going to need to do is then you're going to need to do negative e to the n, which then is going to be divided by 10 to brackets of 1, which then is going to be the integral of x squared dx, which then is going to be equal to negative. We took away the integral since we already integrated. Which then we're going to need to do is then we're going to need to do e to the n x cubed. You guys do the x staying constant throughout the equation due to not having a solved value. So then we're going to need to do is then we're going to need to put that over 310 over 1, which is due to 3 also stays constant throughout the equation, and then also needs to be a constant numerator. Which then the problem is solved. Which then that's going to be the integral of negative e to the n x squared over tangent of 1, which then is going to be dx, which then is going to be equal to e to the n x cubed, which then is going to be over 3 tangent of 1, which then is going to be plus c, due to c being a constant that stays constant throughout the equation. Now, in case you guys are wondering what an antiderivative is, antiderivatives, they are, my address blank. But anyways, an antiderivative basically is an inverse derivative. It basically is the opposite of it. Ultimately, as a primary function to primitive function, ultimately you're going to need to be finding a prime basis vector. Ultimately, what we're going to need to do is that you're going to need to find the f function, the function ultimately of x. X basically means x being a constant throughout the equation. Because, well, since then again, it always is constant, even though n doesn't, even though that doesn't have a value either. Ultimately, you're just trying to find a value that is differentiable out of the equation. That's why e gets out of the equation quick, but then it comes back. Okay, hope you guys like this short video, and I'll see you guys next time.